All right, question. This is 3C it must be. 3C part 3. It says Meg's friend Leo is riding with her, but he begins to decelerate when they reach a speed of 8 meters per second. If he decelerates at 0.2 meters per second squared, how far past the point P will he be when he reaches a speed of 6 meters per second? So let's summarize what we've got so far. So we're starting off, we've got point P. Here's point P. Starting off, and we've reached a point over here somewhere, and this point here is where we've got to. This is after 5 seconds we've been traveling. Yeah. We've reached, so at this point T is 5, but the distance here is 32.5 meters, yeah? And the velocity at this point is 8 meters per second, and we know that from all the previous stuff we've just done. What we now know, though, is from this point, they're decelerating at 2.2 meters per second. So they're decelerating at negative 0.2 meters per second squared. And he's going to keep going now until the velocity goes from 8 to 6 meters per second. Should have left a gap in between there. All right. So let's calculate, or rather factor all of that into our calculation. So all we want to find out is once you get to 6 meters, how far, what is the S value here? S equals, the distance equals. Here it's 32.5, so that's our starting point, if you like. So let's see how far past here, which is how far past P. P's over here. How far have they traveled when they reach 6 meters per second? All right, so first of all, acceleration, we can write that in. Acceleration is equal to negative 0.2. And we want to go from velocity from 8 to 6. So the velocity is going to equal the antidifferential of negative 0.2, increase the power of t by 1, and divide by the new power. Plus, we're going to add in a constant. Was there an initial velocity at this point when all this started? Yes, there was. V was equal to 8. Now we're wanting to find out all of this, and I'll just tidy this up. So V is equal to 0.2. Actually, by the way, I should have written just the integral of A, not all of this, yeah? So I'll just change that. I'll just get rid of that, yeah? But ultimately what I should have written here was V is equal to the integral of A with respect to time. And then it equals all this stuff here. That makes sense. So it's going to be 0.2 to the power of 0.2 times t plus 8. But we want to find it when it's equal to 6. So when is velocity 6? What is that time? So we're going to have an 8. I'm going to subtract the 8 from both sides. That's negative 2 is equal to 0.2 t. So if I've got 0.2, oh, sorry, negative 0. Yeah, it is negative. Negative, negative, negative. So if I've got negative 0.2 t, that is equal to 2. In other words, the negatives disappear because I can divide them both by negative 1. Right, 0.2 divided by 0.2, leaving me with a t. So t is equal to, well, 2 divided by 0.2, 2 divided by 0.2 is in fact 10. There it is. So the time it takes to get here, this is a 10. There's a 10-second gap, this thing here. It takes 10 seconds to go from 8 to 6 meters per second if they're decelerating at 0.2 meters per second squared. Now, well, it's fine. We've got the velocity. We said velocity was the integral of acceleration. So therefore, the distance will be the integral of velocity with respect to time. So what does that equal? S must equal, and I've got my velocity, which is negative 0.2 t plus 8. That was my velocity. Now let's increase the power by 1, increase the power by 1, and add on any constant. Now, do we know any distance already traveled when we started doing this operation here? Yes, we do. Distance was 32.5. There it is, 32.5 meters. All right, seems to be out of focus. Let's see if we can get it back in focus. Focus, 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 focus. There it is. All right, sorry about that. Let's tidy this up. So S is equal to, well, 2 divided by 0.2 divided by 2. So I've got negative 0.2 divided by 2 is going to be 0.1. So it's going to be negative 0.1 t squared plus 8t plus 32.5. Now, the time we know, we've just calculated, is 10. So let t equals 10. That's meant to be an e. So s is equal to negative 0.1 times 10 squared plus 8 times 10 plus 32.5. Let's see where that takes us. So s is equal to, well, 10 squared is 100, and negative 0.1 times 100 is just negative 10. Plus 8 tens is 80, and we've got 32.5 on the end. So we've got 80 minus 10 is 70, plus 32.5 is going to be 102.5, and it's going to be meters. So we want to write some sort of context statement, I think, here, which would be to the effect of, therefore, Leo says, how far past P will he reach? Has travelled 102.5 meters past point P when he reaches V equals 6 meters per second. And that's what I would write.